But if you're new, I'm Carol Little. I'm the coordinator of math for elementary, really ensuring that your child gets a coordinated and well-aligned math education from pre-K through 5. I am going to do a little bit here. We have wonderful opportunities at the school with construction and growth, and sometimes that means we are learning how to be very flexible. So as you all luckily saw the blue signs, you've moved. I'm looking at the numbers that are here, and a lot seem to be missing. So I want to honor the fact that you're here, but I also want to be accepting that there are going to be people rolling in a little bit late. May I ask, how many of you came to the addition and subtraction, I would call it for smaller numbers, in 2nd grade? You can take a deep breath, because as I told you at that one, we are not teaching a new strategy in 1st grade and then 2nd grade and then 3rd grade. We're teaching strategies that hold clear across for addition and subtraction. This is going to be, you're going to see how the kids are now learning how to apply something they already know, but to larger numbers. That is still growth for them, and it may seem obvious to us that if we add 2 plus 3, it's 5, but for them to add 20 plus 30 being 50, rocks some of their world. They're now moving up to 200 plus 300 equals 500. So what may seem very obvious to us who now understand it, it is new learning to them. So we do go back to the conceptual level. We go a lot faster, but we always go back for every student. We move students along much quicker. So today you're going to get a taste of that. We're going to do some things one way with the manipulatives. Now they would always be available in the classroom. So if we move the child onto the representational, the manipulatives are still there. If they get stuck on that representational, they can go back to the manipulatives. But we don't spend as much time the 2nd and 3rd and the 4th go round. So there's been, always talk about, well, when does fluency happen? It happens at very certain grade levels, at a very prescribed way. 2nd grade, your children are to be fluent and have, I would say, automaticity in their facts through 20. So they should be able to add 6 plus 13. Not this and in their face, but do they have a strategy to go, oh, that's 10, 6 and 3 is 9, and 10, that's 19. That's fast enough. They didn't have to struggle with it. They should be able to add and subtract to 100 easily, but not without paper. I don't mean mentally. That is now on paper. They may use many of the ways we're going to talk about here. What we're doing today is at a conceptual level. They would not be expected to be able to do it with just an algorithm. That is for 3rd and 4th grade to develop. So we're giving them the lessons, we're giving them the foundation, and that will keep being built upon. I'm still just explaining. Thank you for following the maze. You should have the pamphlets. I'm going to switch over now. I've gotten nice feedback about giving vocabulary sheets to you. So we're going to quickly run through this. You have it in front of you. We're going to do all of this later, so I'm not sure that you really need to take notes, but this is the language we use with your kids. Compose and decompose, putting numbers together, taking numbers apart. An equation is a mathematical sentence that has 2 equal sides. A question mark can make it equal. So 3 plus 2 equals a question mark is an equation. We don't know the value of that question mark, but it is equal to that. We've learned a lot about the equal sign. Kids, unfortunately, seem to think it means give me an answer, where we really want them to understand that these 2 sides are equal. So a lot of times we talk about 3 plus 2 has the same value as 5. It's amazing how that equal sign. And the reason we know this is, unfortunately, there have been a multitude of studies that asked kids and the older they got, the more likely they were to put 14. Because they only looked at the 12 plus 2. They weren't trying to keep the 2 sides balanced. So we're getting kids younger and younger to realize that's not what that means. So An algorithm is a step-by-step method of solving a computation. This is what we can do once we thoroughly understand it. They are very useful, but they're only useful once the kids understand what they're doing. By this time, I would say your kids are using technically an algorithm for their facts up to 20. They are probably using some form of step-by-step to within their 100, but it may not look like the traditional algorithm to you. Regrouping, I put this up here because it's a very friendly description of composing or decomposing, grouping and regrouping, but it is language we use. I also gave you a pretty picture of the different strategies we're going to go through today. I'm not going to go over them now because that's exactly what we're going to do in 30 seconds. So here is the cheat sheet for it. You also got a letter home from your parents that gave you the same information. I took many of them actually right off the same document. So we're going to get started. Number bonds. Number bonds are a way of showing how we are taking numbers apart or putting them back together. It's a part-part whole, but we start doing it strategically. Friendly numbers or landmark numbers. Those, well, 10, 100, 200, 1,000 are all landmark numbers universally around the world. In the United States, 25 is a landmark number because we deal in quarters and kids quickly learn 25, 50, 75, 100. But if you don't work in quarters, you don't. I moved to Kuwait and really could not understand that there, and I've forgotten the name of it, Durham, came in 20, 40, 60, 80. And the first discussion I had with a little girl, thank goodness it was out in the parking lot, had nothing to do with my classroom. I wanted it to be 25, and here I am correcting a child who absolutely knew what she was talking about. So her landmark numbers in that case would be different. In general, we're often talking about 10 or 100. Those are our friendly numbers. 50 could be a friendly number. 39, not. So that's what we're trying to do, is what can we do to help 39 become a friendlier number? So in 7 plus 8, how can we help ourselves? There's two different ways. I know 10, so I need 3 from this 8 to help me to get to 10. So 8 would break into 3 and 5. I can now add 10 plus 5, and that's 15. I start seeing and being flexible. I also could have done, I could have broken this number apart
7
to 5 and 2. I would have had 10. Of course I got the same answer. Two different children may see that two different ways. It doesn't have to be a first number or the second number. I think a lot of humans naturally break apart the smaller number, but you know you're going to get the same answer one way or the other. So 57 and 15. How shall I break one of those apart? Pardon me?
10 and 5.
Is 10 and 5 going to help me with 57?
No.
Can I get 57? We're going to talk about yours in just a minute. Can I get 57 to a friendlier number?
15, 10.
3 plus
15 and 5.
Then 5.
Yeah, and I'm sorry, the acoustics I'm hearing up front better. So if we do 3 and 12, I've now got 60. And 60 is an easy number. I can go to 72 very easily. 190 plus 130.
That's a question.
Yes.
Because when we do this at home, I'm always expecting him to then write the 60 plus 12 equals 72, but that's not your expectation for homework? Sorry, I want to be clear about whether he's allowed to represent that or it has to be on paper.
I am talking, I'm going to be really honest, I'm talking about the generality of the whole unit.
Okay.
The first day teaching this, I might require that of a child.
Okay.
Would I let that go away? I mean, I expect to see the answer, but to begin with, I might want to see their thinking. So on any given day, that might be what the teacher wants. We're moving quickly. I'm kind of more the endpoints or more so you can see it, so it's going. And some kids are always going to want to do that because it's just a comfort level for them. And then there are going to be kids who need to break this down into 10 and 2 and do that in another step. By the end of 2nd grade, I would hope that the most kids are there once they see that. And a lot of them are starting to do this in their heads. And this is that flexibility with numbers that is so important.
Carol, I have a question. Some students tend to do the branching of numbers in their head. And is that okay, or they need to show their work? Because they're more advanced.
Right.
You can tell they're getting more advanced.
It's kind of the same answer. It probably depends where in the unit. The teacher needs to see that they're understanding it, because if they're not branching it and they're just writing down the answer, they could be doing it so many different ways, and we want to make sure they have this tool.
So encourage the work, but writing the work.
Yes, at least to branch somewhat. And it's going to depend on the instructions, and it's going to, again, depend on the teacher on that given day. But I do want to know that they're using this strategy. Because, yes, there are kids who can just add that.
I know as a private tutor, I know what they're doing.
Yeah.
But and they'll say, but I know, like they've got that down.
Okay.
I know for a fact that they do have that down. So then what do you do?
I had a wonderful answer from a man at a different session. And the parents were saying, oh, but the kids don't want to write it down. They don't want to communicate it. Well, one, communication is a standard. Equal, I would say almost more important than this, because we do have calculators that can do this. Explaining what you're talking about is a much higher level, and this is a form of explanation. And this man said, if I went into my boss's answer and said, here's the answer, 14, and I couldn't explain it and didn't have the backup, I would be fired. So if we think of long-term goals, the real value in this is being able to explain yourself. And this does. Yeah. Now, on the final assessment, when we want to know, can they add this 2 numbers? I don't care if they do it with number bonds. I don't care how they do it in their heads. I am going to ask them to explain what they did. The next strategy to me works a little bit more for that child who does lots in their head. But we want them to have this as a tool so that it can be moved into their head.
Okay.
But yes, there are parts where we want to see it.
Okay.
Go ahead and do the last one. How would you break that apart? Do it yourself and share it with your partner. Oh, I'm sorry, the last one in the row. The last one in the row. My guess is most people broke it apart this way. Again, there's not a right or wrong unless you didn't come up with 320. I mean, we do care about the accuracy of that. So this is going towards friendly numbers. That is one way of using number bonds. The other one is that we decompose it by place value. I can't find an easy friendly number for this entire 3-digit number. So that strategy is not going to work well. But I can break it apart and make the addition or subtraction easier for me. On this one, by place value, well, let's do it. We're going to do the very beginning. We would break it down. This is 200, 30, and 6. This is 400, 20, and 1. There are lots of ways of putting this together. We probably would start, I'm going to start with the kids, but most kids would be led to 200 plus 400 equals 600, 30 plus 20 equals 50, and 6 plus 1 equals 7.
So
Mhm.
doing the chart anymore?
Yes, this is just number bonds. Somehow you flip to a different page.
It's not place value? It's not this? This is not the place value?
No, we're on number bonds page.
Yeah, but
I know it says
decompose.
by place value.
Oh, I'm sorry. Sorry. Place value is a place value. That's place value chart.
Uh-huh.
That's so that
We're doing this anymore.
no, we are. Place value is just meaning that we're doing it by the hundreds, the tens, the ones. We use that as a way of decomposing numbers. So we're decomposing it for the number bonds, we will be decomposing it for the place value chart. These are just different strategies to have in our pocket. And at this point, this really isn't an algorithm. Children should be able to look at that and see 657. Because they're not really adding anything, it's each of the values of the different place values. They'll practice a fair amount with that. Well, and that's probably how they would do both of these.
Excuse
So-
me.
Yes.
Yeah, for that one, is it right to start with the hundreds, to add up the hundreds first, or they have to start with the ones?
No, I don't know if you heard me stumble as I said that. It doesn't matter which they do first.
But I
What
mean,
we will
if the
te-
ones is over 10, it's,
Sure.
yeah.
Okay,
Can we try one
so
like this?
if this happened to be,
Let's say
let's
426.
do 236 plus 459.
Yes.
I mean, we were still going to do. And I just did something that I wouldn't be pleased to see.
Okay.
This still, by time we get to this point, they would know what to do. I mean, we would just talk it through. They're still going to know it's 680. They might break this into 10 and 5 to get to 695. And this is where they have all these different tools to do that with. So it does work with regrouping at all the levels. What I was also going to address is it really doesn't matter if they add the ones first and then the tens and then the hundreds. We get the same answer. What most Western math probably adds the ones first. Most kids generally head towards the biggest numbers first. So we kind of come to that switching of, well, that's fine. It's going to work the same either way. What the brain does like is patterns. I would be very uncomfortable if I saw a child starting with the hundreds first, and on the next problem starting with the tens, and on the third problem starting with the ones, unless I know the child, he's proving to me he can do it. I mean, this is where teachers get very professional. I mean, I've got kids who will do that just to be what I call whippersnappers, and I'd ask them why, and if they can explain to me, I'm just showing you that I can do it, I'd be fine. For most kids, sticking with a pattern ensures that you're doing it correctly every single time. I wouldn't care which way they started. I personally think starting with the middle, I would be hard pressed to allow that to keep going because you're not really. I would let it, if the child keeps getting it right every single time, I would let it go, but it wouldn't be something I would demonstrate to other kids. I would demonstrate to other kids starting either way with the ones or the hundreds, or the ones or the thousands, or the ones in the 10,000s. And now I'm going to correct myself. By 10,000s, we should be using calculators. We understand the math. Yes, they need to do it a few times because there are times when our batteries do die in our phones, but nowadays we do really have calculators. What we really want them to do is to make strategic choices. Please do not reach for a calculator for 1,200 plus 1,300. But 1,269 plus 6,421, I'm probably reaching for my calculator. And it also depends, am I giving something to a boss or to an engineer where that calculation could mean lives, or is it adding up, I don't know, ounces of tomatoes I needed at home, and if I'm off a little bit, I might do that one in my head. So math has really become knowing how to do it and knowing when to be very precise.
So when they're learning it in class, they get to choose?
No, they're not up in the thousands.
I'm sorry. So back to the 100s place.
Yes.
And ones place. Are they able to make a choice? Because
Yes.
my son does start with the hundreds.
Most kids do.
Okay.
It's funny, there's a very natural inclination to start with the largest numbers first.
Yes.
Yeah.
And some of it's because of the way that most people write their number bonds. You usually are picking it up. Now, not all kids do. I mean, the number bond is correct as long as it's equal. But it's unlikely I mean, some of it, they also watch us demonstrate it. It would be unlikely here that they would do 6 plus 30 plus 200. But
You're saying there's no wrong?
I'm saying there's no wrong. I'm saying that your teacher may have seen a pattern in your child. If they can't keep getting it right, they're going to work with them and say, we have to pick away. You need to pick away and you need to do this. But if they get the right answer, that's the right answer. And the number bonds, there will be homework where they have to do it with number bonds. There will be homework where they have to do it with the arrow strategy. And all of that is, if you don't practice something new, you won't get better at it. So we're going to practice. We're going to get you to a point where you have the ability to make a choice. If you haven't practiced it, it's not really in your toolbox. You don't have that choice. Okay, arrow strategy. Again, this has kind of been used since first grade. Arrow strategy was one of my biggest ahas in the last couple of years, because this is the way you can write down what you're thinking. There's no right or wrong way for decomposing these numbers. So if I want to add 42 plus 30, the way it looks is I'm going to start with 42. I personally am going to add 50 to it, because I can decompose that in my head, and I can get 92. Then I'm going to get 3 more, and I've got 95. At the very beginning of this strategy, a child might add 10. They might add 10 again. They might add 10 again. So you get the idea. I'm going to make sure I do this correctly. 82. What's the last one? Plus 3 equals 95. And I know exactly how to talk with this child to get them to progress further, to start seeing larger chunks. So does the child next to them. And this is why we like the kids working together so much, as they see how each other are doing it. Very rarely will the kid who did this turn around and want to do this. They're not going to want to. But this child can see it immediately and go, oh, that does make sense. Sometimes we chunk it. Let's do another one before I say this. So if we have 376, probably going to do the same thing. We're probably going to add 100, get 476, and plus 3 is 479. The reason this is such a twist on the way we used to do it is we're not writing an equation. Because 42 plus 50 equals 92. If I use an equal sign, I now have to start over and say 92 plus 3 equals 95. Because 52 plus 50 does not equal 95. So that is the mathematical difference, which is very huge to a mathematician. And we finally have this way to give kids to write it down easily and simply and correctly. Because before, this is what the kids wanted to do. They were just writing it as 42 plus 50 equals 92 plus 3. Well, that's not true. And it was very hard. They're saying, but that's what my brain says. Yes, that's what your brain says, so let's write it properly as a mathematician.
Well, I think this is a really great way to see what they're thinking, like you say. The only problem is some of them that have to write out the 10 plus 10 plus 10 plus 10, they get lost in that, and then they forget where they're at with the leftover number.
Yes.
So I try to teach scratching out. I'll go back to
Exactly.
and I'll say, okay, mark out your 50. Like literally mark out, scratch out the 5
Yes.
because you're done with the 10.
Yes,
With this
yes.
one.
And then, but
There
I
are
see
lots of
that
things that you're
time
going to
and
have to
time.
do with kids who cannot
Yes.
keep track.
Yeah, that's
I've
the
seen-
most difficult part.
And I've seen check marks. I've seen using this with the number bond, so that the child first had to break this apart before they could do this.
Okay.
I would say if kids are still adding by tens, this probably isn't a great strategy for them. It's probably
Yes.
not going to be the one they choose.
Correct.
I've also worked with a young lady who's struggling, and this is the way she can do it. So this is why we don't pick and choose which strategies to teach. I would have thought that for most kids, struggling kids, this may not be the best. And then I have this one child, this is the one that works for her.
Yeah.
So thank goodness I didn't say, oh no, you should use this one.
Mm-hmm.
But yes, and there's a lot of things.
Okay.
But we want them to see it. I wanted to show you this next one because we're getting into some regrouping. If we add 30, we have 154. I have 9 left. Some kids are going to add 9. To begin with, a lot of kids, going back to that friendly number, they're going to add 6. They've got 160. Now they've got 3 more, and they've got 163. That would probably take some kids needing to break this down to see the 9 and the 6. And these are called double number bonds. I mean, that's far more than you need to know language-wise. So they don't have to do it in big chunks. They can still use that idea of friendly numbers. I'm sorry, gotta be careful. Tell me when I don't do it. It works for subtraction also, and I also want to put in a little bit. Sometimes you can add and subtract in the same one to make it easier for yourself. So 836 minus 405. Most of us would probably take away 400 to begin with, and we have 436. Now I have to take away 5, and I have 431.
Do you, sorry, do you then expect the child to go back and put equals 431? Like if on homework or a test or assessment or something? I know.
You know, homework is about learning. I can't say
Arguments about
exactly what the
going-
teacher's doing. On a test, they have to let us know what they think their final answer is, because there will be a child who has this and then other stuff,
Yep.
and we don't know if that child knows which one is the right answer.
Yes, so you have to.
Somewhere,
write it.
yes, somewhere I want it. I haven't set this up very child-friendly.
No, okay.
It's usually pretty obvious.
You just go back to the equation and write equals.
Yeah, and there's usually an equal sign with a space for it. At the highest level of mathematics, I would have a hard time marking that wrong because it's right.
Mhm.
But if I have to find it, I mean, this is so neat compared to a second grade paper. There is absolutely no doubt that that's the answer. You know, on a second grader's, it's amazing how ambiguous it can be. This last one I put down because, as I just mentioned, let me see if I can think of my thinking. If I could do 770, I might, this is high level, this is a child with incredible flexibility in number sense, I might subtract 400 first. That would give me 370, but I subtracted 10 too much, so I need to add it back, and there's my answer of 380. So I wanted to show you that is how the arrow way can be used. It's not the average child who's going to do that on this particular problem, but there are times where they can go up and down in their thinking. If it's all over the place again, that gives me an insight into what I could be teaching them. On the other hand, it might be that was brilliant in a very clear way of doing it. So we use all this visible thinking to know how to teach the child things. Which might be a way, you know, when a child starts balking at doing the writing and the communication, if they're the type of child to say, but you're helping the teacher to know where you're going next. Okay, could you grab, let's do 5 cubes and 3 cubes. So we're rolling. This took days and days in your child's class, but we've got 20 more minutes. 5 minus 3. The answer to a subtraction problem is called the difference. And the way I have built this is, in particular, the difference model. You can see the difference between 5 and 3, and it's 2. If I add one more to it, to each of the numbers, have I changed the difference? It's still 2. If I add, let's go back to the original. If I take away 2 from each, I still have 2. This is called compensation. It gets to be very brilliant, and it can help you, especially with mental math, that we can get ourselves to friendly numbers instead of yucky numbers. I didn't say that. It's not a mathematical term. So the kids have worked with the blocks. We're towards the end of 2nd grade now. They're fairly aware of the compensation. They've done it with the blocks. We really do move on to the tape diagram to show it. So if I have a tape diagram of 25 and 8, I want a friendlier number. And this is the time that which number you choose actually does make it easier. We're always talking about the number that we're taking away. I don't want 8. It's not an overly friendly number with 25. What would be? 5. Okay, so what we can do is I can take away 3 from both of my numbers. I now have 22 and 5, which really we would write it, we would take that. Did I help myself?
No.
Good try. What else could we try?
Plus 2.
Okay, let's try plus 2. I have 25 and I have 8. I'm going to add plus 2. I now have 27 and 10. Is that an easier one to do?
Okay.
I mean, significantly. So the answer is 17. So what we did was we got, I'm not going to use the mathematical terms because nobody really talks that way, but we used the number that's being taken away. That's the one that we want to get to a friendly number. Usually it's going to be 10 or a power of 100 or something, or 20 or 30, something easily subtractable in our head. So 34 and 19.
And I didn't get it.
Okay,
What was done?
so my original problem was 25 and 8.
Okay.
I added 2 to each of them, so my difference remained the same.
Okay.
But I now have 27 minus 10.
Okay.
So my difference is 17. I'm still trying to find the value here. Okay, so let's try it with another set of numbers and see if it makes more sense. 34 minus 19, for most of us, that's a paper pencil, 2nd grade, paper pencil problem. If I add plus 1, I haven't changed this difference at all, but I now have 35 and 20. Would it help if I wrote those here?
Yes.
I have a problem because I've got a plus 1 there. This is not the clearest. So now I have 35 minus 20. I can count up, I can subtract. I've gotten it to friendly numbers that I'm able to do easily. Did that make sense?
Yes.
Okay? And this is exactly, of course you don't get it the first time. That's why we do teach it over and over again. And that's why we have somebody else explain it, not just me, because I get stuck in the way I explain it. And it's funny how one child saying it with one different word, and you see 3 lights go off in the classroom. It's like, why didn't she say it that way? And it's funny how one word can make a difference.
Yeah.
Hand gestures can make a difference.
That's right.
Okay. You see the idea? Would you do one more at your table?
Yes.
Because there do become lots of choices. I'm going to tell you that this is what we sometimes do. 700 minus 152. For straight out doing it this way, this probably isn't a good strategy. But we're going to talk about this problem later when we've got another strategy and we can start putting two ideas together. Because these strategies can be used together. Are we comfortable with compensation? Or enough? Okay. So now we're moving on to the place value chart, which we brought up earlier. This is where we are using the chips. We're moving towards getting away from having to use representational things. We don't have hundreds in this. We do start using chips that say 100, but the 100 is not 10 times bigger than the 10, and the 10 is not 10 times bigger than the 1. So we've ratcheted up the level of their understanding, but they've had lots of practice with it. So we're skipping you've seen this before, but it was with 2-digit numbers. I'm hoping, can you build, do you have enough tiles at your desk to build, Mike, this isn't going to work well for me, but can you build 314? Because of technology, I'm not going to be able to. Well, I can build it this way. And then we're building the 63. To overlap mine just so you can see them. So now we're able, as addition is, we're able to put them together. We have do this down here. Switch pens. So I have an answer of 379. That's this at its most basic. It's what their whole last unit was about. What we've done is we've just gone up into the hundreds now, or we're going up to 999. And so they're going to start seeing. Looking at confused faces. Did I do the math wrong?
Yes. The first one, 377.
370. I don't know how to count.
7.
Now, I would love to say that was planned. It wasn't. However, as a teacher, if I got that wrong answer and I had the wrong chips out, that is a significant problem. If they've got the chips out and I look at it, I can walk by and say, are you being accurate? That's not a foundational problem. It's just, we want to say sloppiness. It's not sloppiness. That's an error at the moment. But it's not about understanding what's going on. Mm-hmm. This is why we ask to see their work all the time. So yes, I had the right thing out there. Even if I had the wrong thing out there, at that level, it still might not have been a problem. But I'm going to know to question it and to look for it. Is that child making that same mistake over and over? Or is that a one-time thing? And is that about fighting over chips? Is that about what? These things are called discs. They're called tiles. They're called chips. That's not the important part. And in this unit, your kids are going to be moved away from these manipulatives very quickly because they worked with them so much in the last unit. They're available, but most kids are not going to need them. They do need the picture, however. So we took what was there and I drew the exact same thing that I had built. And then I can keep my notation of what does this look like. Well, let me see. I have 300 here. I have 70, and I really want that to be 9 this morning. So I have an answer of 307. Why am I having trouble with that answer? I didn't use this to solve it. I used the place value. I kept track of what I was doing over here. Let's skip the one to the right and go down to the next one. And these would be labeled. If we draw 1, I draw 6. I would probably usually model it using what we call the five trains, 5 dots, because your mind can easily see that as 9 as opposed to random. I'm not going to make a child who's getting it right. I'm still going to suggest it, but if a child refuses to do it and keeps getting it right, I'm going to leave them alone. Most children will switch because, I hate to say it, because the teacher's doing it. But I will talk about the benefit of it. It's not because I do it, it's because there's a benefit to doing it. It also just really helps when we start regrouping. So what do we do when we regroup? We know that we can only have 10 ones. So I'm going to take that 10 and I'm going to move 1 over here. We did that physically, now we're doing it with drawing it. I have 1, 2, 3, 4, I have 5, 10, 15. I can't have 15, I can only have 10. So I'm going to take this group of 10 tens and move that 100 over here. Now I can get an answer. I have 400, I have 50, and I have 3. There we go.
So I think that this is fantastic when it's working properly for the child. I think their biggest struggle right now is keeping the first number and second number apart. And when they do the dots, they kind of run together, and then that actually confuses the child because
Then draw a
there's-
line.
Exactly. And for some reason, that line just makes everything
Yeah.
crystal clear, and then they're able to see the
Yeah.
numbers more clearly.
The line's not going to
Exactly.
hurt, especially in subtraction. That's another ball of wax that drawing the line and putting them there can be a problem because really what you're taking is that you're taking away.
Correct.
And for some kids, mushing them all together really isn't going to rock their world at all.
Right.
Um,
It's different.
So now how are we going to keep track of this? Again, we had 169, 284. What did I do? Well, I regrouped to 10. I put it into the tens place. So I'm going to write that down. And I had 3 left. I regrouped 10 tens and I put it in the hundreds place. And I had 5 tens left. And then I was left with 4 100s.
So they're not putting the 1 on top anymore?
No. That is one of the few changes. Does it matter? No. The reason it came back to brain research is you can actually still see the number 13 and you can still see the number 15. I'm going to show it this way. I'm going to explain that. If a child puts it over the top, do they get the same answer? Yes. If they can explain it to me, yes. The only reason they're putting it over the top, though, is because somebody outside of second grade taught them to. It's not a natural thing to do. And this does make sense to them because they know when we draw this, the chip naturally comes down to the bottom because there's not room at the top. So that putting it across the top is a bit of an artificial choice. If a child's got it, fine, but we're trying to make this as conceptual as possible. And what they did was down at the bottom, and it matches with being able to see that I had 13. That's not a deal breaker. That's not one I'm going to get real upset about, but it is a very much memorized thing to do, and that's against what we're trying to do. We're trying them to make sense of it. Now, this answer, I didn't, with the numbers, sit there and regroup. I got it all from the picture. That is what is expected at second grade. I know there are probably teachers who are seeing kids understand it and letting them go straight to the algorithm. If I had my druthers, I would say no. The standard says they have to be able to represent it visually and have notation at second grade. But this is exactly where kids, what we call, build their own knowledge. Do I want that kid looking at it and going, well, wait a minute, I didn't need that to do that, I understand it. Yes, I want that. But that's not my focus. That's a moment of hallelujah and have them explain it. But am I going to make sure they can explain how they're connected on the test? Yes. Because that's what we're supposed to be teaching them. So they will be, even if they know how to do this, I need to know that they understand the concept. It works the same way for subtraction. We have to break things apart, we move them to the right. So let's do, I'm sure I made sure. Let's do 642 minus 263. Would you go ahead and do that? Well, should I work that with you? Remembering, in subtraction, we are taking them away so we don't draw them. Well, I wouldn't draw the 263 because I'm not adding them to them. I need to take them away. So how am I going to take away 3? Oh, I can't take away 3. So I have to break this one apart and give 10 over here. I'm sorry.
لأنه بالسبتراction is different. They have to start from
Now can I take away 3? Can I take away 60? I can't. I cannot take away 6 tens. I need to break this 100 apart. Give myself 10 tens. Now I can take 6 of them away. And the kids will get very creative as to which ones they take away. They'll start learning to leave the tens together. I'm just taking them from the bottom. I have 7 tens left over. What did I say here? I have 9. I'm taking away 2 100s. I have 3 left. So I have 379. And how does that look if we were to keep the notation? Well, the very first thing I did was I took a 10 away from here. I had 3 10s and then I had 12 1s. Now, as an adult, I'm writing it, just my 1 in there. They're probably having them rewrite it as 12. And then I knew I had 9 left. I came over here, what did I do? Oh, I had to break apart the 100. I had 5 left. I then had 13 10s. And I ended up with 7 10s. And lastly, I took away my 2 100s and I got 379.
They have to show that
Yes.
work as well?
Yes. The point of this is we are moving towards the algorithm. At this point, we've built the algorithm and we're keeping the notation. And they do this and through discussion, not this year, this is not what's required, but in 3rd and 4th grade, they're going to start talking about what is the pattern you see between the two. Can you now do it without building it? So this is what we call notation. I did not solve it here. I had to do it here first.
It's in 3rd grade for the transition? And not have
It's a little bit of 3rd and 4th,
Okay.
yeah, to the standard algorithm.
Is it mid-3rd grade or latter part?
You know, 3rd grade, it's interesting, just dives into multiplication, and that we really come back and revisit. I mean, they will revisit addition. I just don't quite have the standard in my head if the fluency is at, it might be fluency at these levels in 3rd grade and then 4th grade at thousands. I'm not quite sure how it's written. Yes?
For example, in an addition, they ended up with getting tens on the hundreds, would they be able to replace them with thousands? Like, for example, I didn't see the miles and I did this and I ended up with thousands. So would
In
they
second
be
grade, we only go to 999, so we try to be very careful that that doesn't happen. Would your children probably understand it if they built it? Absolutely. But technically, we only go to 999.
All right.
Okay, so you've got the idea that it is extending. Oh, we're good. It's 9 o'clock and I'm finished. So it really is, these are the same things they did in their last unit. This unit, they are going to have to start picking which strategy and telling us why. So this idea of understanding that, oh, if I break it apart by place value, I can do such and such. If I break it apart to a friendly number, I can do it in my head. So they are going to want to be able to do that. Now, I do want to go back to the one problem that I thought I skipped. It was an ugly one. Where did it go? Oh, there it is. The 700 minus 152. If we started this one with compensation, if I took away I'm just going to take away 1, and I'm going to tell you why. Because at this point, this is lots and lots of regrouping. This is where kids traditionally have the most trouble. If I take away 1 from each, I now have the problem 699 minus 151. I still can't do that mentally. But if I now go to my place value chart, I'm not going to be doing all the regrouping. So now I've got 600 and now I can take 151 away, which is a lot easier. I can take 1 away, I can take 5 away, and I can take 1 away, and I'm done. That's a sophisticated level of knowing to get rid of my zeros. So I used compensation to change the problem. I still needed the chip model to solve it. So what did I end up with? I've got 8, 4, and 548. The only thing I saved myself was from having to take one of these, cross it out, put it over here. But our kids, because we have them thinking about strategies, kids will figure out how to do that. They'll figure out how to use them together to make things easiest for them. There's no need for that, but there will be kids who see it. So these strategies don't stand alone. One strategy doesn't work best for small numbers and doesn't work for big numbers. It all depends on how the numbers come together. So again, your kids get a lot more practice at this. We're showing you the glimpse of it so you understand what they're asking. Not yet, but as it develops, I would be asking the child, why, that's a big question. Why did you choose that strategy? Which strategy is easier for you? On the last test, we accepted which did you choose and why, and they said because it's easier for me. And that was great for the last unit. This unit, we're going to want to say, what about the math was easier? And this, I believe, is going to be the last session for second grade. Their last unit is on understanding, how do I even say it? It's called multiplication and division. It's not, it's skip counting. It's groups of, and especially 2s and 5s and 10s.
They're figuring it out though.
Absolutely.
Places, I know like 1s times 2s and 2s.
Yeah. Yeah. And I'm gonna say now, and they're going to say it very strongly, this is not about memorizing times tables. It's about understanding what it is, because we really shouldn't be doing, oh, they've learned the 1s, oh, they've learned the 2s. If that's true, there's like 144 facts. If you know that table, it's a square, I'm not gonna be able to draw it exactly, but it's 10 groups of 10. If you know this quadrant, you know all the answers. You have to understand that 3 times 2 is equivalent to 2 times 3. That's sophisticated. That is not sophisticated. That doesn't come till they're mature and in 3rd grade. Right now, we're just wanting them to understand that there is an easier way of counting up groups than by single numbers. You can count 5s by skip counting. You can count 10s, and that's where we're going with that. It's not a big, it's not nearly as tricky as these are. So, thank you for coming. I'm glad you found the room. That was a fun part. If you could put your things back in the boxes or baggies, that would be fabulous, because I've got to get them back to teachers so they can use them today. And if you have any other questions, Wednesdays from 2 to 3, I sit in Mindy's office, and I'm always available for particular questions. And I can take particular questions. Yes. Oh, thank you. Oh, also on the very back sheet, there are some websites. If your child is finding this easy and you want to stretch them, these are different. These are not particularly about arithmetic. They're often logic or the puzzles or that. But these are good websites to keep kids engaged. Thank you.
Mariam is so happy. She came about your grandma and grandfather.
I need
She's
to
so,
know
she loves
if
it. She lost her grandfather.
if she were to
So
just
she's so
write that
happy.
down, I know.
She was so amazing.
Yes, but that's what she's showing. Yeah, she wants to make a good share.
She likes Jana. Thank you very much.
I mean,